right, in this example, we have a ladder leaning against a house, and we're being asked how high on the house the ladder reaches. So this time they're giving us a situation and asking us to represent a diagram, or it'd be helpful if we had a diagram to represent this. Could someone come up to my screen and draw and label the diagram with the measurements in place? Can you come up to the screen, please, and draw the diagram, putting the measurements in place? Chris, go ahead. Fantastic, yes. Very frequently, I'll have students put the 12 here because they didn't read the question where it says the ladder leans against the house. From here, we're doing exactly what we just finished doing on the previous screen. We're setting up and solving an equation for x. One person, please. What will this equation look like? Helena. Fantastic. X squared plus 4 squared equals 12 squared. Simplifying our equation, we have x squared plus 16 equals 144. So x squared is 128. And notice this time the instructions are asking us to the nearest 10. Read the questions, ladies and gentlemen. This time, we don't have to worry about simplifying the radical. Just evaluate in your calculator what the square root of 128 is. So that's 11.4, 3. And then I'm seeing a lot of you. Let me have your attention up here, please. I'm seeing, as I said, a lot of you get the mechanics of where to start with this problem and what numbers to plug in and how to solve for x. And a lot of you have something like 11.2 on your paper. But it's not the answer to the question. Question is asking you how tall was the tree to begin with. That 11.2 that you found is how much of the tree looks like this. You have to add it back to the 5 feet that's still standing. Okay, the correct answer is 16.2. Before I go any further, if that 11.2 didn't come to you, the 16 you're not seeing, then that's a conversation I want to make sure to have. Yes? Okay. Visually, what you needed to realize, gentlemen and ladies, let's go ahead and turn the CENTIOs off. They're not cooperating with us today. Sorry. Okay, what you needed to realize in this problem is that this was a tree, and it was very beautiful. And then lightning struck it, and this fell here. It struck it 5 feet above the ground. And then when it toppled over, it's touching a point on the ground 10 feet from the base of the tree. So you would use Pythagorean's theorem in order to find the hypotenuse of that triangle. 5 squared plus 10 squared equals x squared. Okay, so those of you that had the 11.2, you solved for this diagram beautifully. But once again, it's that matter of reading the question. Guys, ladies, gentlemen, I know some of you may think, Mrs. Clouse, she's out to get us. She throws these awful questions at us. That's what the EOC is going to be, ladies and gentlemen. And I'm not trying to trick you. I'm trying to prepare you because that's what you're going to see. You've got to read the question. So once you found that x, you needed to add it back to the 5 in order to find the height of the original tree. Okay, we have from this screen what we need. Okay, the Pythagorean theorem has a converse, of course, that we can use to determine what kind of triangle we're looking at based on the lengths of its sides. I hope that you realize that the strict converse of the Pythagorean theorem, well, let's rehash what the Pythagorean theorem says. The Pythagorean theorem says if right triangle, then a squared plus b squared equals c squared. I would hope that you'd realize that strictly its converse is saying if a squared plus b squared equals c squared, then it's a right triangle. Okay, so if a triangle has side lengths a, b, and c such that a squared plus b squared equals c squared, then the triangle is right. When we are using these inequalities to determine what kind of triangle the triangle is, we'll put these phones away, ladies and gentlemen, it's not going to help you. I would urge you, instead of thinking a squared plus b squared and c squared, flip the whole expression around and start with c squared. It's just a lot more intuitive that way. Okay? And what I mean by that is, look at what it says in your notes. If c squared is greater than a squared plus b squared, what does your gut instinct want to think that this is when you see that greater than sign? Obtuse. Exactly. Whereas, if you were looking at this inequality the other way around, you'd be looking at the same numbers, but you'd be looking at a less than sign. And that less than sign may lead you astray to thinking that that's an acute triangle. So again, I really want to stress to you, put the c squared on the left so that the answer looks the way it should look. Okay? And then finally, if c squared is less than a squared plus b squared, the triangle is acute. So in problem 4, I have a triangle with those side lengths. I'm being asked, is this a right triangle? What you're being asked, ladies and gentlemen, is, does a squared plus b squared, in fact, equal c squared? So that's what we're checking. It's a yes or no question. Yes. Problem 5 is asking us a more general question. It's not asking us specifically whether this is a right triangle. It's asking us what kind of triangle this is. And since that's the way it's asking it of us, once again, remember the biggest piece of advice that I can give you about this kind of problem. Bring the c, which is of course your longest side, over to the left-hand side of the expression. So I have 12 squared, and I'm trying to determine what's going to fill in the blank of this expression. Because if it's equal, it's right. If it's greater than, it's obtuse. If it's less than, it's acute. Okay, so 12 squared blank, 4 squared plus 9 squared. And then we're simplifying and comparing. This is 144 and 16 plus 81. I would put a greater than sign between those values, and that would make this triangle obtuse.